So alternating series. Alternating series. Alternating series whose terms alternate between positive and negative called alternating series. That means one term is in this series, if first term is positive, second term will be negative, third term positive, fourth term negative, or like first term negative, then the next term will be positive. Such series is called alternating series. So sigma example, sigma k equal to 1 to infinity minus 1 power k plus 1 1 by k, which is equal to here 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, etc. And another form is sigma k equal to 1 to infinity minus 1 power k 1 by k, which is equal to minus 1 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5, etc. So these two are examples for alternating series. In general, an alternating series as of the form following two forms. First one, sigma k equal to 1 to infinity minus 1 power k plus 1 ak. This is ak, right? That means minus 1 power k plus 1 ak, which is a1 equal to a1 minus a2 plus a3 minus a4, etc. And the next form is my k equal to 1 to infinity minus 1 power k ak, which is equal to minus a1 plus a2 minus a3 plus a4, etc. That means positive and alternate between terms alternate between positive and negative. So there is a test to check whether such series is convergent or not. That test is called alternating series test, and I will define what is alternating series test. The next topic is alternating series test. An alternating series either of form 1 or form 2, either of form 1 or form 2, converges if the following two conditions are satisfied. That is, this alternating series converges if these two conditions are satisfied. The first condition is a1 greater than or equal to a2 greater than or equal to a3 greater than or equal to etc. ak greater than or equal to etc. So that is, we have a term ak must be greater than or equal to ak plus 1 for all k equal to 1 to, that is ak greater than or equal to ak plus 1 for all k. That is the first condition. And second condition is limit k tends to infinity ak. Limit k tends to infinity ak is equal to 0. That means this term is equal to 0. Then if an alternating series satisfies these two conditions, then the series converges. So this test is only applicable for alternating series. So now we will do few examples. First example, use alternating series test to show that the following series is convergent. So the first series is sigma k equal to minus 1 power k plus 1 1 by k. So the first series given is sigma k equal to 1 to infinity minus 1 power k plus 1 into 1 by k. So here ak here. So what is ak here? Ak is equal to 1 by k. Now first we have to show that. So we have to check whether first condition ak greater than or equal to ak plus 1, and the second condition ak limit ak equal to 0. So for that we know so we know k is always less than k plus 1 for all k equal to 1, 2, etc. So this is for sure, k is always less than k plus 1, which implies if you take the reciprocal 1 by k, then this must be greater than or equal to 1 by k plus 1 for all k equal to 1, 2. Okay. So what is 1 by k? 1 by k is ak, and what is ak plus 1? 1 by k plus 1. So this implies ak greater than or equal to ak plus 1 for all k. So the first condition is satisfied. Ak is greater than or equal to ak plus 1. Now for the second condition, if you take limit k tends to infinity, ak, which is equal to limit k tends to infinity, ak here is 1 by k. 1 by k. So this limit is equal to 0. So the second condition is also satisfied. Therefore, the series converges. So the both conditions for the alternating series test of the alternating series test satisfies. Therefore, this given series is convergent. Now we will look at this series. Sigma k equal to 1 to infinity minus 1 power k plus 1, k plus 3 divided by k into k plus 1, k plus 3 divided by k into k plus 1. So first we will write what is this series. Okay, so I will delete this portion. So given ak, so here ak is this part, k plus 3 divided by k into k plus 1. So first we have to show that ak is greater than or equal to ak plus 1. So it is enough to show that ak by ak plus 1 by ak is less than 1, which implies ak plus 1 less than or equal to ak. So in order to prove ak greater than or equal to ak plus 1, it's enough to show that ak plus 1 divided by ak less than 1. That means ak greater than ak. So for that, ak plus 1 divided by ak plus 1, this is equal to ak plus 1, k instead of k plus 1. So k plus 1 plus 3, k plus 4, k plus 1 into k plus. So this is ak, k plus 4 divided by k plus 1 into k plus 2 into all divided by ak. So we will take multiply with the reciprocal into k into k plus 1 divided by k plus 3. So this and this get cancelled. So it implies ak plus 1 divided by ak is equal to k into k plus 4 divided by, if you multiply this, k square plus 5k plus 6 is equal to k square plus 4k divided by, you can write k square plus 5k plus 6 is k square plus 4k plus k, 4k plus k, 5k, k square plus 4k plus k plus 6. So denominator is less than, denominator is greater than numerator, so this is less than 1. So ak plus 1 divided by ak less than 1, which implies ak greater than or equal to ak plus 1. Ak greater than ak plus 1. So the first condition is satisfied. Any doubt? So just we take ak plus 1 divided by ak, then ak greater than ak plus 1. Now limit k tends to infinity, ak limit k. Now we want to show that limit k tends to infinity ak is equal to 0. So limit k tends to infinity ak is equal to limit k tends to infinity ak is k plus 3 divided by k into k plus 1. Now if I take a k outside, k square outside, so this is simply equal to limit k tends to infinity, k square I am taking outside, so 1 by k plus 3 by k square, and also from denominator I am taking k square outside, so 1 plus 1 by k. So what we will get is this, as k tends to infinity it is equal to 0. So limit ak is equal to 0 and ak greater than ak plus 1. Therefore by alternating series test, yes, this series converges. Series converges. Okay, now we will do few examples. Okay. So now you write down this problem. Show that the series converges by confirming that it satisfies the hypothesis of alternating series. So you do these two problems, and these 6 problems are your homework. So I will share these questions in your WhatsApp group. So first you do this problem, first one, and tell me the answer. So we can do this problem together. Now tell me limit k tends to infinity minus 1 power k plus 1 divided by 2k plus 1. So what is ak? Tell me what is ak?
1 by 2k plus
1 by 2k plus 1. Now what is ak plus 1? 1 by
2k plus 3.
2k plus 3, right? So first we want to show that ak greater than ak plus 1. So for that, how we will show? We know that 2k plus 3 is always greater than or equal to 2k plus 3 is always greater than or equal to
2k plus 1.
2k plus 1. It implies 1 by 2k plus 3 is less than or equal to 1 by 2k plus 1. So what is this? This is actually ak plus 1 less than or equal to ak for all k. So that means ak greater than or equal to ak plus 1. Any doubt?
Sir,
Hmm.
sir, less than or equal to എടുക്കുന്നത് സാറേ
No, there is no problem. Okay, less than or equal to or greater than or equal to or greater than. It's or greater or equal to.
ഓക്കെ
Okay, there is no problem. If you can write like this also. Greater than. It's the or condition. Greater or less than. Hmm. So if you want, you can take this is strictly greater than 2k plus. So this is there is nothing wrong in that. And now the first condition is satisfied, like right? Satisfied. Now what about second condition? Limit k tends to infinity ak, which is equal to limit k tends to infinity 1 by, what is ak? Ak is
1 by
1 by 2k
1 by
plus 1.
1
1.
by 2k plus 1. What is this limit? Limit 1 by 2k plus 1, 1 as k tends to infinity. This value is
0.
0, right? 0. So both conditions are satisfied. Therefore, the series converges by alternating series. Now, I share these questions in your WhatsApp group. You just work it out. If you have any doubt in any of the question, you can send me message or you can ask. Okay. So is it clear alternating series test? Alternating series test is clear. Then we will move to absolute convergence. So if you have any doubt, you can ask me. I hope. So today we will define what is absolute convergence of a series. So absolute convergence. Okay. A series sigma k equal to 1 to infinity uk is equal to u1 plus u2 plus etc. uk plus etc. is said to converge absolutely if the series of absolute values, that is sigma k equal to 1 to infinity mod uk, which is equal to mod u1 plus mod u2 plus etc. mod uk plus etc. converges and is said to diverge absolutely if the series of absolute values diverges. Okay, that means when we say that the sigma k equal to 1 to infinity uk converge absolutely if it's a sequence of absolute values, that means series of absolute value mod uk converges, and diverges absolutely means sigma mod uk diverges. So we will take an example. Determine whether the following series converges absolutely. So first series is 1 minus 1 by 2 plus minus 1 by 2 square plus 1 2 sorry plus 2 2 2 raised to 3 plus 1 by 2 raised to 4 minus etc. Then what is the absolute value? This is u. Okay. So this given series is 1 minus 1 by 2 minus 1 by 2 square plus 1 by 2 cube plus 1 by 2 raised to 4 minus 1 by 2 raised to 5 minus etc. So what is its absolute series? There is no negative terms, right? 1 absolute values 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 raised to 4 plus 1 by 2 raised to 5 etc. Is this series is convergent? What you can tell about this series series of absolute values?
Converges.
Converges, right? Because this is a geometric series, right? 1 divided by 1 minus 2, which is equal to 2. So this is a geometric series. Therefore, the series given series converges. Now, what about the second series? This this is actually 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus etc. So this series is actually a alternating series, right? K equal to 1 to infinity minus 1 power k plus 1, right? But is this series converges? We already showed that this series is convergent, right? But does it absolutely convergent? That is my question. So this series, we know that this is convergent by alternating series test, right? From where we already done this series, right? This is actually 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, etc. So that series converges. My question is, does it absolutely convergent? What is the absolute value of this series? 1 minus then plus 1 by 2, 1 by 3, plus 1 by 4, plus 1 by 5, plus etc. So what is this series? This is actually sigma k equal to 1 to n, 1 by k. Is this series convergent? Is this divergent? Because it's a p series with a p equal to 1, therefore diverges. So that means even if a series is convergent, that doesn't imply it is absolutely convergent, because this series is convergent actually, because it's sorry this series sigma k equal to 1 to infinity minus 1 power k divided by k. This is convergent but not absolutely convergent, because its absolute value not absolutely convergent, because its absolute value doesn't converge. Okay, so any doubt?